Oh, okay. All right, so I'll go ahead and share my screen, right? Are you able to see it?
Yes.
Okay. So I guess we'll wait for 2 more minutes before we get started.
No waiting.
No waiting?
No IST.
Okay, so we'll get started then. We just have about I guess 6 attendees.
And
Okay,
three of
all
us.
right
So,
then.
yeah.
So let's get started. This is our first meetup session for this year. So happy New Year! I know we are 2 weeks into this year, but still, wish you a very happy New Year, and for showing up for yourself, for learning something new. This is our awesome team. First one is me, Anuja, Mohit, Olga, Win, Shin. I think Shin joined the call, and Senthil. And of course, Paresh is the mastermind behind all of this.
Slim pickings, a mastermind. Okay.
All right. And these are the sessions that we had last year. Oops, sorry. All right. We had pretty awesome sessions last year and hope to continue doing so this year as well. And of course, you can pull up your chair and get some drinks and food if you like. But I would recommend getting a notepad or something to get some notes. All right. So your host for this evening is myself, Anuja, and Paresh. And thank you to Microsoft for being the global sponsor for all the meetups related to SQL Server. And of course, our speaker tonight is Haripriya. She's going to talk about TempDB contention. So we'll learn about SQL performance tuning and some valuable insights into that. So I guess, Haripriya, you can take over.
Thank
I
you,
can also
Anuja.
add that the recording will be available on the Google Drive by the end of the week. Okay. And the PowerPoint presentation that she has or anything else will also be in the same folder. So whatever whatever Haripriya can share will be there. Sorry, Anuja, that should have been told.
All right, over to you, Haripriya.
All right. Thanks both. Let me go ahead and share my screen. All right. You see my screen, right?
Yes.
All right. Hello, everyone. Thanks for joining this evening. Today, I'm going to be discussing about TempDB contention. This is one of those performance problems I've learned the hard way in my earlier years as a database administrator. So I want to make sure you have all the right tools if you were to happen this, if this were to occur on your production servers, so you can have all the right tools and handle this smoothly. Okay, this doesn't. Okay, it's working. And about myself, I've been working as a SQL Server database administrator for 10 years now. I'm very passionate about databases. I love diving into the internals of the SQL Server engine. And I work a lot on AWS EC2 instances with SQL Server installed on them. And I'm an AWS certified solutions architect. And also at the beginning of, not this year, it's 25 already. Wow, I can't believe. So last year, I won the award that's called Rookie of the Year at work for the work I did in 2023. So I got it in 24. So that's about me. And the agenda for today, we will be discussing about what TempDB contention is, what are the different types of contention that you can see in TempDB, how do we identify it, and what are the different ways we can resolve it. What is the need to learn about this TempDB contention? So you have slowness on your system, and to troubleshoot that slowness, it is really important for you to understand how that slowness occurs. it could have been caused by TempDB. So for you to resolve that slowness, it is very important you understand what this contention is all about. And speaking about concurrency management, if you take any production server, you have hundreds or thousands of concurrent transactions running. To manage them all effectively, again, it is very important you understand not to cause contention. So that way you can resolve any contention that is caused and manage all those concurrent transactions on your production servers. At the end, you will see that how we were able to address the slowness and also how we were able to manage all those concurrent transactions. So why is it about TempDB? Why not the other user databases? In a SQL Server instance, you have multiple user databases. You have many operations going on like inserts, updates, and deletes, and many things. But if you take TempDB, any temporary object operations like temp tables, table variables, or even version store, if you use different isolation level like snapshot isolation or read committed snapshot or online index operations, any of those things, all of that is going to happen on TempDB. And you have only one TempDB for the whole SQL Server instance. The workload can be 10 times more or even 100 times more on TempDB compared to any user database. That's why there is contention on TempDB. So what are the two types of contention? We have object allocation contention, that is of the DML type, and metadata contention, which is of the DDL type. We will be looking into each of these contention types in detail, and we'll do the demo for these two as well. First one is the object allocation contention. So when you have inserts, updates, or deletes running on these temp tables, every time when these operations run, they need to acquire a latch on three special pages called PFS, GAM, and SGAM pages. When there are only a few operations, you can easily get a latch for those operations to run. But when you have too many of these, then there is going to be contention on these three special pages. So normally in systems, you will not have that many operations. Like for if you take on dev or test, you will not have that many inserts, updates, or deletes running on temporary tables. But on production, especially on OLTP systems, like very busy OLTP systems, you're going to have too many of these operations, for example, running in stored procedures or things like that, then that is going to cause contention. And this is called object allocation contention because to allocate the objects, contention occurs. And that's why it's called object allocation contention. And it's important to understand that this contention is about PFS, GAM, and SGAM pages. It occurs on these three pages. These three pages are special pages in every data file. I'm not going to go into detail about these pages. They're out of the scope of this session. So I'm just going to tell you that these three pages are special pages and latches are needed on these three pages for the operations to finish. When there are too many operations, then there is contention on these pages. So if you see in the picture here, you have multiple transactions hitting on this data file, and they are waiting to acquire a latch on these PFS, GAM, and SGAM pages, and that causes contention. So that's how this object allocation contention occurs. And this is a tempdb.mdf. And for example, you can have one file or 4 files or how many other files you have. If you have too many operations and you have less number of PFS, GAM, SGAM pages, then that's going to cause contention. And about these page numbers and details about internals about PFS, GAM, SGAM pages, I've written in the blog there. And if you're interested, you can take a look at it. So once this occurs, how do we identify it? You will see page latches and you will see the wait resource something like this. Let's decode the numbers. The first number is the database ID. Database ID 2 is always for TempDB. And the next number 4 is about the data file. You don't have to remember that. And the next number, the last number, is the page number. That page number, you can find out what that page is from the page type description column. So page number 2 is GAM page. So what you need to know is, if you have page latches, wait type page latch on GAM page, SGAM page, or PFS page, on these three pages, then you know it is object allocation contention. Instead of these three pages, if you see anything else like sys allocation units or system objects or any other pages, then that is not object allocation contention. That is something else. All right. And also about the wait type. In this session, we are only going to be talking about page latch, and it is not page IO latch. Page IO latch is completely different. It's about bringing the pages from storage to memory. So, that's another topic, and we can discuss that probably in another session. For now, all you have to remember is we are going to be talking about page latches. And object allocation contention means you will see page latches on three pages, PFS GAM and SGAM. And how do we resolve this? So getting this picture again, where you have one data file and multiple transactions are hitting, they are waiting to acquire a latch on PFS GAM SGAM, and that causes contention. In order to resolve this contention, what you can do is add more data files. If you add more data files, you get more PFS GAM and SGAM pages. Now the transactions, they are spread across the multiple files. Once they are spread across the multiple data files, now contention is automatically reduced because you have multiple data files, which means you have multiple PFS GAM and SGAM pages. All right, so this is how you have this object allocation contention reduced, because you have multiple data files. And now you can think about how on our production servers or any SQL servers, we go and add more number of data files on TempDB. And this is the reason. It's because you get more PFS GAM SGAM pages by adding more data files, which means you can reduce the object allocation contention. All right, so let me just get this real quick here. Okay, and so there is round robin across the multiple data files and PFS pages that reduces contention. On the data files, it always round robins across the data files. Don't get that confused with the log files, because log files are always sequential, one by one. But data files, it will round robin across the data files. So that helps in reducing contention. And another important thing is you have to increase the data files always in numbers of 4. And if you still see contention, you can increase in numbers of 8. So if you have, like, for example, if you already have 4 data files, add another 4 data files and check for contention. Don't do like 2 or 3 data files. So you always do it in additional numbers of 4 or 8. And the other thing is you create them with equal size. That's very important. Imagine you have existing data files, each of 4 gig. Then if you create another 4 data files, you are creating them as 4 gig too. Whatever you have the existing data files, you're creating them with the same size. Only then you can have the round robin algorithm work efficiently. Because if you have files of unequal sizes, then it is going to follow proportional fill algorithm, which means it will just focus, or all the transactions will just go onto the data file that is bigger. So we don't want that to happen, because that will create hotspots. So always create files with equal size. And if possible, if you are in a maintenance window or during the weekends, if you get a chance, go ahead and restart the SQL service when you're adding the data files. Because when you restart the service, TempDB gets started from scratch. So the existing data files and the new data files that you just added, everything will become equal size, which means equal empty space. So everything will start from 0. It will have an initial size, but everything will become empty. So which means they all have equal empty space. So that will also help address contention a bit. So it's not a must, but if you get the opportunity to restart the SQL service, go ahead and do it. So the key point here is add data files in numbers of 4 or 8 with equal size to reduce this contention. And if you see the server version, in 2014 and earlier, you must have seen trace flags 11.17 and 11.18. But from 2016 and onwards, you don't need to turn on these trace flags, which help in addressing TempDB contention, but you don't need to turn them on because they're already on by default. And in 2019, they addressed the latches on one of the pages, especially on PFS page, where you needed exclusive latch. They updated that latch to a shared latch. So on 19, you will not see contention just on one of these special pages. But on 19, you will still see contention on remaining two pages, GAM and SCAM pages, which they addressed in 22. So if you are on SQL 22, you will not see this type of contention. That's the TempDB enhancement that has been made in this 22 version, because PFS, GAM, and SCAM pages will all share the latches. They don't need exclusive latches for the operations. So you will not see this type of contention on 22. That being said, you should still follow all the best practices across all the versions. And if you have a very hard time with this contention on your 16 or 19 or 17 servers, I will recommend if you can migrate or upgrade to 22, because this has been working really well. You will not see this contention on SQL 22 version. All right.
So
this
all
is
the
about
3 pages where the contention was are now gone in 2022.
That is correct.
Thank you.
Yes.
Sorry.
No worries. Any questions? So this brings us to the end of first type of contention. Any questions? Anyone?
Guys, feel free to type it. Yeah.
Yeah, feel free to go ahead, and if you have any comments, please feel free to leave them. I'll be more than happy to answer them. What is the significance of increasing data file in numbers of 4 or 8? So what I will say is, which I'm going to be showing you in the demo as well. So if you add 4 data files, you get 4 more PFS, GAM, or SCAM pages. That's going to address contention. But if you're still seeing contention even after adding those 4 data files, you can do 8. It really depends. For example, in one of the production servers I worked, I had 64 data files, but still contention was not resolved. So having 64, I felt like it made sense to add 8 instead of just adding 4. So I did 8. There was still contention, added another 8. There was still some contention, but I could see it was getting reduced. So we added up to 96 data files. And this is, I think, on a server with 196 processors. So 192 processors, if I'm right, yes, and with 96 data files. So if your question is about if you have to do 4 or 8, start with 4, see how things are going. If you see it getting reduced, add another 4. But if you see okay, nothing is happening, or you just see a very little difference, add 8 and see what happens. It's just about as you keep doing, you'll get the hang of it. Okay, I think you're typing something. Okay. All right. Okay, cool. So that's about the first type of contention, where you will see page latches on PFS, GAM, SCAM pages. Once you see that, you will add data files in numbers of 4 or 8 with equal size. And on 22, you will not see this type of contention. All right. Now the second type of contention, that is the metadata contention. Earlier we saw it was because of inserts, updates, or deletes happening. So there was the contention because of inserts, updates, and deletes. And this contention is due to create, alter, or drop, basically DDL operations. When you're creating the tables, temp tables, or altering them, you will see this contention. For these operations, it needs a latch on system object pages. Earlier we saw for inserts, updates, and deletes, it needed a latch on PFS, GAM, and SCAM pages. For this DDL operations, it needs a latch on system object pages. And like I said, on very busy OLTP systems, when you have too many of these operations, that will again cause contention on these system objects. I'll show you the picture here, so that will help you understand better. So if you see, you have multiple operations going on, and they are all trying to acquire a latch on one of the system tables. For example, in this case, is system object values. So that is causing contention on this system table page. So this is how contention occurs when you have too many of those operations running. And in this picture, only one system object is displayed. But when you actually do the operations, there are 12 system objects that these operations need to get a latch on. Not necessarily on all 12, but a few of those 12 objects that it will need to get a latch on, and it causes contention on those system objects. How do we identify this? Here you will see page latches on system objects. Any objects that start with the name sys, and if you see page latch on system objects, then you know it is metadata contention. In the first type of contention that we discussed, it was page latches on PFS, GAM, SGAM pages, just those 3 pages. Here you will see page latches on system objects. So that's the key difference between these 2 types of contention. So TempDB has these 2 types of contention. Page latches on PFS, GAM, SGAM pages, and this one is page latches on system objects. All right. And how do we resolve this? First thing, I know we are very interested in cleaning up our temp tables. You don't have to do it. Do not drop or truncate your temp tables. It's because SQL Server will do it asynchronously for you behind the scenes. You don't have to explicitly drop any temp tables. Just create the temp table, do your work, and just leave it. SQL Server will drop them for you. And this is based out of optimistic latching algorithm. Well, let's not go into the details of algorithm. But what it will do is it will asynchronously drop the tables for you when your session is done. And when SQL Server will drop that is based on the number of concurrent alter or drop operations it has. It will see or wait for a quiet time and it will drop. All right. So if you are actually dropping your temporary tables, you can feel free to go ahead and comment those lines out of your stored procedures. You can go test it on, your dev and QA and implement it on production as well. We have done that and it really, really helped a lot. And I see a question, what about global temp tables? This does not apply to global temp tables. This is only for local temp tables. Good question, by the way. Yeah. And yes, so because this will also help you reduce the number of page latches. Probably, I think I should add that point there. This does not apply to global temp tables. Well, I will do that. Thank you for bringing that up. And so first thing is, do not drop your temporary tables. And second thing is, cache your temporary tables as much as possible. And how do you do that? When you create a stored procedure, and when you create the temp table inside of it, do not create an index outside of the temp table. Like example, if you see in the screenshot here, you see how I'm creating a temp table and then doing the index outside of the definition. Do not do that. If you do that, that is going to invalidate the cache. The temp table will not get cached, then it cannot get reused. So do not do that. Instead, what you can do is bring that index inside the table definition. You see just in the parenthesis that whatever index or whatever keys, whatever you want, create them in line with the table definition. That way, the temp table can get cached and it can be reused. Because once you do that, you are reducing the metadata contention, which means you are reducing the number of page latches it needs on the system objects. And another thing is, whenever you create a temp table, and if you want that to be cached, wrap it up inside a stored procedure or a function or a trigger. All right. So there are, a few key rules for caching, and out of them I've mentioned the common 3, which is when you create the index, do not create them outside. Instead, create them in line with the table definition and wrap them up inside the stored procedure. So you have these things like avoid dropping your temp tables at the end of the stored procedure and try to cache your temp tables. So doing these 2 that I just talked about will help you, like 40 to 50% of metadata contention will get resolved, because that's what happened in my case. we implemented this about caching these temporary objects and also avoid dropping the temporary objects. This helped in a significant improvement in reducing the metadata contention. Though this will not completely get rid of this metadata contention, you can see that significant enhancement in reducing this contention. All right. And also, if you want to completely get rid of this metadata contention, there's a new feature in 2019, which is called the in-memory TempDB metadata feature, also called the memory optimized feature. So what this does is, it's actually part of that in-memory OLTP umbrella that we have. So this is only for TempDB. TempDB gets in-memory now. Not the whole of TempDB, but the system objects in TempDB. So this one, it is not on. You have to turn it on if you think you need it. And what this feature does is, it will move the system objects to memory. Once it gets moved to memory, now those objects will become latch-free and lock-free. So you will not see page latches on these system objects anymore. So that again helps the remaining whatever metadata contention you have, it will help you get resolved. So this is one of the features, new features in 2019 that you can take advantage of. And this is how you enable this feature: alter server configuration, set memory optimized TempDB metadata on. And if you also want, you can set up the resource pool, but that's up to you. Once you play around with this feature, and if it helps, you can do the resource pools as well. And these are the 12 system objects that this feature moves from its storage to memory, or from cache, you could say, to a special place in memory where you don't need latches or locks, and it will become lock free, and this metadata contention can be resolved. So metadata contention, if you have DDL operations, too many DDL operations running, then they will need a latch on system objects. So once you see page latches on system objects, then you know it is metadata contention. To resolve, you can avoid dropping the temporary objects. You could cache your temporary objects by creating the index in line with the table definition and wrapping it up inside a stored procedure. After you do all of this, if you still have metadata contention, then you can turn on this feature starting SQL 2019. So this is about metadata contention. Let's take a look at the questions. Does it matter if we do select star into or create temp table and then insert into? Yes, actually it does. And I've also written about it, and I also answered in Stack Overflow about that. So when we speak in terms of temp tables, what we should be doing is always create the table first. Create the table first so that table can get cached, and then dump the data into the table. Especially if you're using this inside a stored procedure, first create the table and then do that insert into. So that actually helps a lot, because if you are going to execute that stored procedure many times a day, you can actually cache that temp table, just reuse the metadata, and only keep inserting the data. That will help reduce a lot of page latches. So that's what I do in my stored procedures. First, create the temp table, whatever you want, like if you want indexes or whatever you want, first create it and then insert the data into the temp table. All right, I can also tag the link if you like from Stack Overflow, right? Yeah, probably at the end of the session, I can paste the link in there so you can take a look. I've explained it even more. All right. Yeah. But it also depends upon, if you're not using it in a stored procedure, if you're just doing it outside, just a regular thing, it really doesn't matter what you want to do. So yeah, so if you want to cache it, if you're using the stored procedure, you want to do it many times a day, then first create it and then do the insert into. All right, okay. Any more questions? We are going to head into the demo. So if you have any questions, just let me know.
We're in good pace.
Okay, sounds good. All right, let me bring up. So what I'm going to do now is cost contention in 2019 and in 22, both the versions, and I will show you the difference, how it is in 2019 and how different it is in 22. All right, so first let me do this on 19. Let me show you the version. I have 2019, CU27, and the number of processors, I have 14. So the TempDB data files that I get with the install is actually 8. Okay, I haven't added anything yet. We just have 8. And I'm using the stored procedure. It's just a simple stored procedure, but I just got it from class Aspenbrenner. What this does is creates a temp table with 3 columns and then inserts 10 records into this. So let's go ahead and create this. And before doing this, I want to tell you about this ostress utility. This is a free Microsoft command tool that I downloaded that you can, do a stress against this a SQL Server to see what issues or what wait stats you get out of it. So you can do it on your, for example, you can take a workload from production and then run it on your dev or QA server and see what issues you get out of it. So that is how this tool is used, or you can also stress it how much you want and see what issues you get out of it. So that way you can, implement the solutions in production. This has been a very helpful tool, especially when you want to test certain things. So that's the tool ostress.exe. And I'm using my server. And this is the script execute the stored procedure, populate temp table that we just created here. N50 means run on 50 simultaneous threads. R1000 means run it for 1,000 times. So we are running this for 1,000 times on 50 threads. So that will cause contention, and we can see what waits we are getting and how to resolve it. And before I run this, I also want to show you the script that I'm going to be using to check contention. So I'm filtering this by page latch because we are only interested in page latch waits for today. And DM exec request, that will give you the currently active request. And that, when used in conjunction with this SQL text, it will pass the SQL handle so you can see what SQL text you're getting out of it. And FN page res cracker, this is a new 2019 function. And DMDB page info is also a new function in 2019. So these two functions, when used together, it will give you all the page related waits. So you can troubleshoot the page related waits, which in our case is the page latch. All right, so if I were to run this now, we shouldn't see anything because I don't have anything running yet. What I'm going to do now is go ahead and run this ostress utility. So let me run this ostress 2019. Okay. Okay, worker threads created. Let's go check it here. What contention we see. Okay, so we see something. Let's see. So we see page latches. And if you see the object, we are seeing this on system objects. System objects are nothing but metadata objects. So that means it's metadata contention. So this is how you find out what contention it is. So you can see what resolution you have to take. Okay. So page latches on system objects. I'm going to scroll all the way to the right. Okay, I get the allocation type, metadata contention, and I'm going to scroll all the way to the end to see if there is any other type of contention. For now, we just have metadata contention. And the ways to resolve metadata contention, like I said, in the stored procedure, do not create an index outside of the stored procedure, which we didn't do. We created the primary key in line with the definition, so that's good. And do not drop the temp table. Yes, we didn't drop the temp table at the end of the stored procedure. That's good. And then wrap the temp table inside the stored procedure. So that's good as well. We have followed all the caching rules. And also we did not drop the temp table. That is good as well. And the third thing that I said is to reduce the metadata contention is you can enable this new feature. So this is off by default. It's 0. We can turn it on. So I'm going to go ahead and turn this on. But after I turn this on, it needs a restart of the SQL services. So let me go ahead and restart because the DLLs, for the DLLs to take effect, we need to restart the SQL services. It's this side. We need to restart the SQL services. And yeah, don't do it from SSMS like me. It's just a sandbox. So I'm just doing it from here. And when you do it, also do it from, do it on, both active and passive instances, or primary and secondary instances when you do. All right, this is just a standalone instance, so I'm just doing it on one instance. All right, so now I turned it on. If I check, it should be 1, so that's good. And if you see how many tables, you must see 12 tables moved. That's good. So these 12 system objects have been moved to memory. So that means these all will be latch free now. We should not see page latches on these objects. If you see previously, I just want to show you this. If you see this contention, you see this is alloc units. We actually should have this here. This result set is nothing but what objects have been moved to memory so they can be latch free. So in the earlier window, we had this one. There were page latches on this. Now that we turned on this feature, now this object have been moved to memory. So next time when you run this contention script, we should not see this. All right. So that's what I was going to explain with the objects here. Now that we have moved these objects to memory, how much memory it is occupying? It's just 81 meg. It's absolutely nothing. So that's good. So what I'm going to do now is, the only change that I made is enabled that in-memory TempDB metadata feature. No other changes have been made. I'm going to kick off this same load again. Okay, good. I see page latches now on GAM page. I don't see any system objects anymore. I scrolled all the way down. I don't see anything. So that's good. We resolved this page latches on system objects. No system objects here. That is because we enabled that feature where it moved everything to memory, making them latch free. All right. So all I have now is page latch on GAM page. I'm going to scroll all the way to the end, allocation contention, right? All the way. And okay, all I see is allocation contention. And you know, allocation contention means it is waiting to acquire a latch onto this GAM page or SGAM page or PFS page. So we can resolve it by adding multiple data files. For now, we have 8 data files, which are default. What I'm going to do now is add 4 more, 9, 10, 11, and 12 of equal size. I'm going to add, okay, because before I add the 4 files, what I want to do is grab this perfmon. What is this? This is 2019, right? Okay. The reason I'm bringing this up is when I add the data files and check contention, I won't be able to see if I made any, impact. Like I can see the page latches reducing, but I really want to see how the graph is, how much contention is actually being reduced to get the metrics. So before adding anything, what I want to do is I'm going to again kick this off, get a copy of how contention looks like now. All right. So the green thing is the throughput, the workload that's running, and the red is the page latches. You see the red, that's the page latches. All right. So let this be like this. It will finish in a few seconds. All right, so it's done now. Okay, so now that we have this, what I want to do now is add these 4 data files. So whatever graph we got now is from 8 data files. I'm going to add 4 more. So this has total of 12 data files now. So that's good. I have 12. What I want to do now is start this up again. You see, maximum we had 14,000, right? 14,000 latches. I'm going to start this up again and kick this off to see if anything reduced at all. Okay, what do you see now? You see 6,500. Okay, it's going up. I see 6. Okay, so that's like 7,000 maybe. Okay. The workload finished. That's good. Okay. So here is the difference I wanted to show. You see the last time it went up to 14,000. Maximum we had 14,000. We added 4 data files, and how much do we see now? Less than 8,000. That's like what? Maybe like 60, I think 14 to 8 means like, I would say like maybe 40% of reduction. That's a very big reduction, right? So you see the number of page latches that has gotten reduced. So that's the reason I brought up perfmon, because in SSMS, you could tell, yeah, you see the page latches, but how much were you able to make that impact? Like how many page latches got reduced? So that's the reason I bring up perfmon to exactly see if the data files that I added any value or not. So here you could clearly see you went down from 14,000 latches to close to 7,500 latches. Okay, so here it says 7,378. Okay, so that's good, right? So what I'm going to do now is add another 4 more and see if it's going to decrease even more. All right. And we have a question here. Now that everything is in high-speed flash storage, still doing this building tables in memory, how useful is that? What is it, Paresh? I don't get it. Still doing this and building tables in memory?
Yeah, so when you said you moved them to the memory, right?
Yes.
So, but these days, because the flash storage itself on which the TempDB usually resides,
yep,
is as fast as the memory, taking this extra step, is it helpful enough?
Yes, it is. Actually, yeah, okay. We have tested on different types of storage and everything. I do find it helpful when it moves to memory. You can see the number of latches being reduced.
Thank you so much.
Yeah, thank you. All right, going back to our topic. So you see, we added 4 data files and the spike got reduced. What I'm going to do now is I will try adding another 4 data files and see if it helps at all. Right? So 13, 14, 15, and 16. Let's add this. Now we should see 16 data files. That's good. And let me turn this on and then kick off the workload. So the only difference now is we added another 4 more compared to this previous graph. Let's see if it gets reduced at all. Well, not really that much, almost the same. Yeah, maybe just a little bit, not that much. Okay, so at this point, I'm not going to go ahead and add any more data files because you can clearly see the impact there. Like absolutely nothing. So that's how you make this decision. Like, okay, so I'm seeing this reduction in spike. Let me add 4. Okay, at this point, I don't see anything, so I'm not going to do anything. You see how it works. So you can make that informed decision, especially by using perfmon, when you have to add the data files, because you'll be like, should I add more data files? Is it even reducing or not? Things like that. And to be very honest with you, I was never a big fan of perfmon, or I never used perfmon in my daily work or something. But for things like this, it's really helpful. So, if you want to play around or do something like that, it does help a lot. And once you get a hang of it, you can do a lot of stuff with, not just with perfmon, and also with not just for adding data files, for many other things like for version store or anything with TempDB and many other things. Perfmon does help a lot. All right, so now we added the data files, we reduced like maybe 50%, and that's it. So I'm going to stop it at this point. So this is about 2019, the allocation contention, where you have to add the data files. You cannot completely get rid of this allocation contention, but you will be able to mitigate it to some extent by adding the data files. All right, and metadata contention, the second type that we discussed, that you can cache the temporary objects and you can enable that in-memory TempDB feature. So this is about 2019. Let's see how 22 is. I'm using exactly everything the same, except the version is 22. The same workload, perfmon, everything will be the same. All right, the same store procedure. 20. Okay, good. I checked this. 22. Okay, let's see. Where am I? 22. That's good. And this should have 14. And TempDB data files, we should have 8. That's default. Okay, I'm using the exact same store procedure that we did in 2019. All right, so 3 columns with 10 records in it. And this is the same OStress utility that we just used. The only change is the 22 version here. And before I kick this off, I want to show you the contention script. It's also the same thing on 20. Okay, let me get 22. Okay, so if I run this on 22, there's absolutely nothing now. That's good. And let me go ahead and run this utility. Okay, bucket that's created. Let's check contention now. Okay, we see page latches on system objects. Metadata contention, right? So let me scroll through metadata. Okay, all we see is metadata for now. And our store procedure looks good. So let me go ahead and enable this in-memory TempDB feature that we just did in 2019, right? So I'm going to enable it here on 22 as well. So if you check now, oh, it's already one. I don't know how it's already one. Should have been off. Let me see. Oh, I'm on 2019. I'm like, oh my God. Sorry, I should have got this done. Okay. So I'm on 22 version and this is 0, which means it's disabled. So let me go ahead and turn this on. And for this to take effect, we should restart the service. So I'm going to restart 22 now. That way the DLLs can take effect. All right, so it should come up in a few seconds. So when this comes up, you will see the value 1 now because it's enabled. That's good. And let's verify if we have all 12 objects moved to memory. That's good. And how much memory is it occupying? 83 meg. So that's fine. Like I said, this system object will now be moved to memory. So we should not see this page latch anymore. Now, when I run this now when I run this workload again, because I've enabled that in-memory TempDB metadata feature. So we are doing this on 22 and we saw metadata contention. So I enabled the in-memory TempDB metadata feature. What I'm going to do now is run the same workload again, and let's see what page latches we have. Absolutely nothing. Let me check again. Okay, nothing. Okay, so we were able to resolve metadata contention. That's good. But we didn't see allocation contention here at all, right? So before I trust SSMS fully, what I want to do is when this workload is done, okay, so this is done. I also want to check in perf on. Maybe there are some page latches and maybe we are missing that on SSMS. So I don't want to take a chance and I want to kick this on here. So I turned on perform and I'm kicking off the workload again. Let's see if there are any page latches at all, especially the allocation contention. As of now, what we see is page latch. If you see, it's all 0. It's a red flat line. We don't see anything at all and the workload finished. So I'm going to pause this. So what did we see in 22? We only saw metadata contention and we enabled that feature. We didn't see allocation contention at all, which is nothing but the contention on PFS, GAM, and SGAM pages. We didn't see that contention at all. We only have 8 data files. We haven't added any new data files on 22 version. And we also checked in perform. There's absolutely no contention. All right, but you have to remember on 22, you still have metadata contention that you have to address. Only the allocation contention part is gone. All right, so here we saw 2019 and 22. On 19, we have both allocation and metadata contention. We addressed allocation contention by adding the data files. We were able to mitigate it to some extent and not completely resolve. Metadata contention, we were able to resolve. Same thing on 22. Metadata contention, we were able to resolve. Allocation contention, there's absolutely none on 22 version. So this brings us to the end of demo. Any questions?
This is cool. Thanks.
Okay. Thank you. And finally, just a couple things. I want to discuss about the common mistakes that we have been making in TempDB contention, including myself. It's not always about data files. Like we just saw in our demo, we have 2 types of contention and only allocation contention can be addressed with data files. Metadata contention, which are the page latches on system objects, that needs to be addressed by caching the objects or by turning on in-memory TempDB feature. Adding data files will not help metadata contention, and that is very important to understand. And I know there's this huge, misconception that TempDB contention is resolved, and I see people talking about, on Stack Overflow or on other websites. Oh, I thought TempDB contention was resolved. I still have it on my 22 server. Of course, you're going to have it on your 22 server because only the data file part is resolved. You don't have to add any more data files. Only that part, the allocation contention part is resolved by default in 22. metadata contention still exists. You need to address it manually even on 22 version. And talking about this new feature in-memory TempDB feature that I just showed, be very cautious if you have to use it on 2019. I don't recommend using this on 2019 because you can see unexpected server restarts during the day because of this feature on 2019. But it does seem to be working fine on 22. You can enable this on 22, but on 2019, you have to be cautious if you want to enable it. All right. Okay, I know I've given a lot of information, and if you find it difficult, or I understand it's not easy to retain all of that, just have this flowchart handy. And the next time when you encounter TempDB contention, just use this flowchart and you should be able to freely handle it smooth. First thing, do you see page latches? And no other wait types. This is just about page latch. Do you see it? Yes. You see it on TempDB? Yes. Are they on PFS GAM SGAM pages? And if that is yes, now add 4 data files of equal size or 8 data files of equal size. Now check for contention. Do you still have contention? Now add another 4 or 8 data files of equal size and go in that loop. Again, check for contention. You can again add the data files. Okay. Okay, so it is not on PFS GAM and SGAM. Instead, you see the page latches on the system objects. What do you do now? Cache your temporary objects. Don't drop your temporary objects in the stored procedures. After you do that, now you check for contention. And if you still see contention, turn on this in-memory TempDB metadata feature in 22 version. So there are these 2 directions to it. One is if it's on PFS GAM SGAM, you go in this direction. If it's on system objects, you go in this direction. Because don't get confused with these 2, because I've been confused too. That's why I put this flowchart out. It's very important you understand that if it's PFS GAM SGAM pages, you add data files. If it's system objects, you address the metadata part by caching or by turning on that in-memory feature. All right. And it's very important you understand that this green box, this part is resolved by default in 22. Only if you're in version 19, 17, or 16, you have to manually address it. In 22, this green portion is completely resolved by default. But you still need to address this metadata contention, which is the bottom one. You still need to address that manually, even in 22 version. I hope this really adds value to your, for the time and effort that you have put in here. Yeah, thank you. So,
there are a few questions, ma'am.
There are? Okay, let me go back to the chat window. Where's the chat? So
my question is that,
okay, is there a script to figure out how much extra memory was consumed by the in-memory objects? How much? Yes. Oh, yes. Get this out. So in the demo, right, if you look at this, how much memory, right, in the metadata contention script. Okay, if you look at this, this should give you see how it was 80 gig earlier, 80 meg earlier. And now after we moved the objects and we performed the workload, you see how it is 300 meg now.
Okay.
So the system objects, yes, they are now occupying 300 meg. So you can use this script to find out how much memory those system objects are actually occupying.
So it's not that bad. It's not in terms of gigabytes or like our OLTP tables that tend to be in memory. They can be terabytes too, right? Okay.
Yes, so then, those are for user databases because you have user tables in memory. This is in TempDB only for system objects. User objects will not go to memory because of this feature. Only only the system objects will go to memory.
Okay, then what happens to the, there are a couple of other questions, one from Olga and Manish, right? But I'm going to bypass them for now. Okay. So what happened to that common wisdom of not going more than 8 files on TempDB?
And I didn't get the question, Parish. What is it?
So the common wisdom is like, not more than 8.
Oh no.
10 GB files.
Yeah. Okay. So I'll say this. So if you have 4 processors, you will get 4 data files by default with the server installed. If you have 8 processors, you will get 8 data files by default. If you have 16 or 32 or how many ever processors, you still get 8 data files by default. With the server install, you only get 8.
Okay.
But if you are on 2019 or earlier versions, you can go ahead and add 4 more data files if you see page latches on PFS GAM SGAM pages.
Okay. Only
Yes.
under that condition. Okay.
Only if you see page latches on PFS GAM SGAM. Only in that condition, data files are going to help. If you see anything else, data files are not going to help.
Cool.
Only for these things. Yeah.
Olga, she's the boss also.
For example, it should be like this. If you see this, yeah, it should be like this. Page latch on GAM, SGAM, or PFS. Only then it's going to help adding data files.
Okay.
All right. Yeah. Sorry. Go ahead with the question.
And Olga, Manish has the question that we are still having a few SQL 2017 servers. Is avoiding dropping temp tables and caching the temp tables.
Oh, definitely. Okay. Anywhere from 2014, this caching or avoiding dropping temp tables will help. Anywhere from 2014. Yeah, even on 22. From 2014, these things will help. Yes.
Beautiful. And then Olga also, because she's also another boss here. So she's asking, what if the TDE is on?
Does it matter if TDE is on? I don't have TDE on, or I've never played with the TDE, so I will not be the right person to answer that question. But from what I have seen, I haven't tested this myself. But from what I have seen, TDE should not affect this, because I know TDE affects the IFI, instant file initialization. But with this TempDB contention part, everything should remain the same, is what I'm thinking, but I haven't tested it myself. Everything should remain the same as my guess. Yeah, TDE shouldn't affect it. Yep. All right. Okay. Any more questions? Yeah.
This is a good time to ask questions, guys. If you still want to hang around, and if you have any suggestion as to what topics you would like to see, I think Chin is typing a question. Okay. What kind of data files to add? You mean like the LDF?
TempDB data files, .ndf, right?
NDF.
Let me show here. You know, the one I just added, where are they? Yeah, like this, alter database, add file. I mean, this is my sandbox, so I have it in C drive, but don't do it on your C drive if you have on your service. But it will be something like this, tempdb.ndf. Only the first file will be MDF, next everything will be NDF. Does enabling CDC affect? No. So CDC is on the user databases, right? It's going to affect the transaction log though. Yeah, you will have an effect on the T log, but nothing will happen to TempDB contention. This contention is still going to be there even with CDC. So the extension doesn't matter? You're asking or you're telling?
I think the gentleman, I think Shashi was that. I think Paul was saying that extension doesn't matter. I think he is answering Chin's question.
Oh, okay.
Yeah.
All right.
Oh, yeah. I forgot to tell you, Chin is another boss. So.
Okay, Paresh, come on. Who is not a boss now?
No, we have a great team here. It is absolutely.
That's nice to hear. Yeah.
Now I don't miss Boston anymore. Sorry, Haripriya.
You are so unkind, Paresh.
Yeah, absolutely.
Right.
Cool. I think this is it. If you have any other questions, if you just want to hang around and talk about what to expect. Oh, yes, we have the AI Saturday coming up, folks. That is on 22nd March. If you do feel you can learn something more there and contribute to yourself, your company, that may be a good time. I think did we put that in our slides, Anuja?
Yes, so I didn't get to that part of the slide.
Aha, okay. So you want to go ahead and show it now? There's I think the same number of people.
Thank you,
Haripriya, one of the things is we almost never get people past the 7:30 hour. So this is terrific. Kudos to you. So,
thank you.
I remember I told you we are expecting about 1/3 people, right? And that's exactly the number of people showed up. So
yep. No worries, Parish. I think it's all, even if it's 1 or 2 people, I really don't mind because it's about, was it helpful to them? Yeah, that makes me happy.
Yes,
That's
absolutely.
it.
Yeah, cool.
Yeah, Haripriya, it was just so good. Like, we could understand. I mean, this is not something that I do in my day-to-day work, but then still, like the way you presented it, it just makes so much sense. And I think I can try it myself too. So
Okay, thank you. Thanks. Thanks to hear that it was helpful. Yep.
Okay, so Haripriya, she's
I'll
going
stop
to,
sharing.
she's going to share it now. And she
Okay.
forgot, I think we just handed it over to you too quickly.
Yeah.
So,
Um, all right, all right. Oh no,
oh yeah,
just a minute.
yeah. You forgot to share the right monitor.
Yeah.
Wait till you get to my age in the 40 years. Yeah, sure.
Where am I? All right. Are you able to see my screen?
Yes.
Okay. All right. I didn't know what you wanted to cover in the announcements.
So the announcement is where you actually say that Deepti Goguri is going to be talking
Okay.
about
I see. Okay. We
February
have
20.
slides for that. Okay.
Yeah,
I'll
okay.
get to
Right.
that.
And jobs exchange, if anybody's looking for a job and anybody's offering a job, this is a good time to exchange. Make sure your boss is not here.
All right. So these are the upcoming events, SQL Saturday and Data Saturdays. Yeah, if I
So
guess
Damu, you want to talk about SQL Saturday Atlanta? I can unmute you, sir. Give me one sec. Go ahead, Damu. If you'd like to talk about SQL Saturday Atlanta.
Yeah, I can. Hey, Paresh, thank you for the opportunity. Haripriya,
Absolutely.
that was a great session. Thank you. That was good. As always, and you've done a great job.
Thank you.
It was good. So we have a SQL Saturday AI and BI edition coming up on the March 8th here in Atlanta. And the link is on the SQLSaturday.com. And if anybody wants to come over, please do. And we are evaluating the sessions right now. We got like almost 170 sessions submitted. So it's like a huge thing to go through right now. So we are trying to filter all the stuff and get to it. And we have 4 pre-cons on the day before on the 7th. So that would be, additional thing that you could attend as well if you want
So give
any
me
deep
one
dive
sec.
sessions.
Yeah, so that is really SQL Saturdays are about too little about too much. And the pre-cons are too much about too little. So that's like the deep dives for you, just so you know.
Yeah. So we have like a prompt engineering pre-con and a PowerShell pre-con and a Fabric pre-con and a real-time intelligence pre-con. So 4 different pre-cons on the 7th. So
Beautiful. Thank you.
thank you
Okay,
very much.
folks,
Thanks.
I think we can call it a day. Remember AI Saturday coming up? And yes, meetup session
Yes.
next
And
month. It is not on a Wednesday, it is on a Thursday. So you don't want to add that. But sorry, I interrupted too much.
no, that's okay. And then this is the next meetup session that we have coming up next month. I'm still not sure about the exact topic, but I know Deepti will be talking about Azure. So we'll update you on that very soon. Um, that's it. Thank you all for attending.
That's me and Haripriya.
Thank you.
In
Yeah.
November.
From
Yeah,
past
that's
summit.
pretty. Yep, absolutely. That was really awesome. Cool. Thank you, guys. Have a great rest of the January. And I will see you next month sometime. Anuja, awesome job. And Haripriya, as always, delighted to have you and see you in person or at least virtually. That was awesome. Take care, guys.
Yep.
See
Thanks,
you.
everyone.
Good
Bye.
night. Bye-bye.
Oh, we have to
Thank you.
stop the recording though. One sec. Stop recording. Okay.
Okay.
So Anuja,